Hi everyone, today's video is about linear expressions and nonlinear expressions, and the main thing is to tell the difference between the two and what they are. Alright, so on your note packet we have a table with these different expressions in them, and I say take a minute and look at the following expressions. Now, what makes them expressions and not equations is that an equation always has an equal sign. And you'll notice that none of these have an equal sign in them. Alright, so it says take a minute and look at the following expressions. If I told you to separate them into two groups, well, how would you separate them? Alright, and there's many answers to this. I'm sure people could come up with many different ideas. But how I would separate them is looking over these different expressions. I notice that some of them have x's with exponents that are simply ones. Alright, I could put in a little 1 right here, because if there's not an exponent there, that means it is understood that there's an exponent of a 1 there. Alright, and some of them do not have an exponent that is a 1. This one has an x squared. This one has an exponent on that x that is a 1. Alright, this one has a 1. This one has a 1 and a 1 here. This one also has a 1 and a 1. This one, though, has an x squared. Alright, I'm going to put a circle around that one. And I'm going to put a circle around that one. This one actually has an exponent. If I distribute this exponent here, it has an exponent of a 3. And this one has an exponent of a -4. So if I were going to group them, one way you could do it is based on the exponent that is on the variable, namely x. Alright, and that really is what linear versus nonlinear means. Alright, and I'm just going to define this. I'd like you to jot these down as well. In a linear expression, the exponent, sorry, not the exponent, I'm going to take that out of there, the variable has an exponent of 1. Now you could go a little further and say that when I graphed this, if I turned it into an equation and graphed it, it would graph into being a straight line. But these aren't equations. These are simply expressions. So a nonlinear expression, the variable has an exponent of something other than 1. Alright, and that basically has an exponent other than 1. Okay, so that's a big difference between these two, and the expressions we look at today, I believe mostly are linear type, okay, because really you don't get into nonlinear type until 9th grade math or much later in this year. Alright, so let me take that off of here and let me switch up to this exercise number 1, and it simply says the expression 57 minus x is a linear expression. Alright, and that goes along with what we just said. This variable, this x, has an exponent of 1. However, the expression 20x squared plus 9x plus 5 is not a linear expression. So why is 2x squared plus 9x plus 5 not a linear expression? Alright, well, what we just said. Alright, this is not a linear expression because it has a variable with an exponent of 2. So underneath this, I would simply write the second expression. Alright, or you could write it all out, 2x squared plus 9x plus 5. But I'm just going to say the second expression has a variable with an exponent other than 1. Okay, and that's really all we're after right there in exercise 1. Alright, now in the future we're going to turn these into equations, and if I were to graph say 57 minus x equals y, turn it into an equation, put that equals y in there, I'm going to get a straight line. Alright, but if I were to graph this one, say I turn it into 2x squared plus 9x plus 5 equals y, then I'm going to get actually a parabola. It's going to be a shape that looks like a big U. Alright, but we don't have to get that complicated right now. Okay, so let me turn this one off. And here's exercise number 2. Now it says, let's examine the expression 4 plus 3x to the 5th more deeply. To begin, we want to identify the terms of the expression. Alright, and this is something new where they ask for the terms. Now terms are usually separated by pluses and minuses, and sometimes division symbols, but sometimes not. It just takes practice to recognize these things. But if I look at this expression, I want to separate the terms. Well, this plus sign separates this term. There's one term. Okay, I'm going to label that. That's the first term. And it separates that term. Alright, there's the second term. Notice that I didn't separate the 3 and the x to the 5th into two separate terms because those are being multiplied together. Multiplication does not separate an expression into different terms. Okay, so how many terms are there? Well, the answer to this question is there are 2, 1 and 2. And what are they? Well, we already put them in their boxes, so there's the first term and there's the second term. Alright, and we're taking this very slowly, guys. This is if you understand the parts of expressions and the parts of equations, it makes them so much easier to solve. Alright, so we're going to get to that pretty soon in solving them. Okay, let me turn off this one. And let's put the next 2 up here. It says, how many terms does the expression 7x plus 9 plus 6 plus 3x have? Well, notice I added in this little parentheses right here. So let's simplify this first, okay? And whenever you want to list what terms there are and how many terms there are, you want to make sure that you simplify the expression first. So to piggyback what we did last year is we picked out like terms. And like terms is simply any term that has the same variable and the same exponent on those variables. We're going to call those like terms. So I'm going to put a circle around anything that's a like term with the 7x. Well, I look at the 9 and it doesn't have an x on there, so that's not like terms. There's not like variables there. I look at the 6 and those aren't like terms, but I look at this 3x and those have like terms. And I want you to notice the way I circle this. I included the symbol, the mathematical symbol that's in front of it, because that's going to help me combine them. Alright, people always have trouble when they start combining like terms and they have positives and negatives. Well, this expression only has positives, so it's pretty easy. So I'm going to say to myself 7x plus 3x, and whatever, notice how I said plus 3x, whatever is in front here, that's what I'm going to use for my mathematical operation. Alright, so 7x plus 3x, well, that simply gives me 10x. And then I'm going to switch over to a different color and I'm going to circle the positive 9. Again, notice I'm including the plus sign that's in front of each of these terms here. And I'm going to combine those as well because those are like terms. They don't have any variables, so anything without any variables are going to be like terms as well. So 9, positive 9 plus 6 just simply gives me 15. Alright, so there, I'm all done. I've combined the like terms. Alright, there's my new expression. And now we want to know how many terms does the expression have. Well, now that I've simplified it, it has 2 terms. And what are they? Well, one term would be 10x and the other term would be 15. Okay, so not too bad. Not too bad. Hopefully you followed that one. Alright, let's try the same thing with this one. How many terms does the expression have? Oh, I have a multiplication symbol in there. And again, we want to simplify first. So go to your order of operations, and order of operations says do the multiplication first. So I'm going to multiply these two together. And I do not need like terms to multiply items together, alright, or multiply terms together. So I'm just going to bring down this 5, and I'm going to take 9x times 7, that gives me 63x, and I'm going to bring down the 2x to the 9th power. Alright? So, and then I want to say, well, can I combine anything else? Can I add anything else? Well, this 5 does not have any x's, so I can't combine it with these two. The 63x to the first, remember that's to the first power, that is different. That is not like terms with x to the 9th, so I cannot combine these two. So I've simplified everything I can. So now let's circle the terms up here. Here's one term. Alright, there's the first term. I'm going to label that first term. Okay, I don't know if you can see that R right there. I'll take that out and make it better R. Alright, and I'm going to switch over to another color. Here's some green. Here's another term, because this 63x has a variable with an exponent of a 1. So here's the second term. Alright, and oh, I need another color. How about I go, let's see what kind of colors I can get into. Oh, I can just go back to black. That works. Alright, here is the other term. That would be my third term. Okay, so again, we're not solving anything, we're just identifying terms, and if you can do that, it makes your life so much easier when you go to do algebra. Alright, so let me turn those off, and let me turn on this last set of exercises here. And it says, is 94 plus x plus 4x to the negative 6 minus 2 a linear or nonlinear expression in x? Alright, well, remember a little bit ago we said if it is linear, then that means that the variable only has an exponent of a 1. Alright, so I can see right here I have a variable of an exponent of negative 6. So it's definitely not linear. It is definitely a non-linear expression. Alright, and when they say why or why not, I can simply put this expression is non-linear. Alright, non-linear because it has a variable with an expression, not expression, take that out of there, with an exponent that is not a 1. Simple as that. Okay, as soon as I see an exponent with a variable that's not 1, then I know I have a nonlinear expression. Okay, it could be something that's parabolic, it could be something that's exponential, it could be something that is, something else that has something. All of those are exponents that are not equal to 1. Alright, and the last one here is the expression x to the first plus 9x minus 4 a linear expression in x. Well, again, this x not having an exponent means that it is a 1. So both of these have an exponent of 1. So yes, it is. Simply put, yes, it is. Alright, and the reason we know that is because all of the exponents are 1. And really, we could simplify this 1x, okay, if there's no number in front of the x, that's a 1. This 1x plus 9x is simply 10x minus 4. Okay, so if I simplify it, I could simplify it down to 2 terms, and we could say yes, it is a linear expression. Alright, so that's all I got for you right now. Thanks for watching, and hopefully everything went well for you. You understood everything that we did. If not, you can watch it again, and we'll catch you tomorrow.